So this is the column we want to find quantities of concrete that will be used to cast this column. And then let's just go to drafting and annotation, then click on 3D modeling, and under the view let's have a southeast isometric like that. Then you click on graceful, then the height of this column is 3 meters. So then we can just change the view to, let's say, conceptual. So this is the column. An example is you have a column like this on site, then you need to find quantities of materials used in concrete to cast this column. That is what you're going to measure on today. So our column measures length 400 millimeters, width 200 millimeters, and height 3 meters. So the first thing that we're going to do, let me just show you in this window. We're going to use it. Let's use large text so you can see. So we are going to calculate the volume of concrete. So the first step, it's very simple. The normal volume we calculate like volume of a cuboid. The volume is given by length times width times height. So in this case it's just 0.4 by 0.2 by 3 meters, which gives us as we are calculating, as everyone is calculating theirs, which gives us 0.24 cubic meter. So that is the volume of concrete that will fill this column. Now it's cubic meters. Let's just do that there. You should just know it's cubic meters. Then the next thing, we want to calculate the quantities of cement, sand, and ballast used in the concrete. So what you need to know first before you can proceed is the class of concrete that you'll use. In this case, we're going to use class 25 concrete. After knowing the class, you need to know the mixed ratios of that class. Class 25 is a mixed ratio of 1 to 1.5 to 3. 1 being cement, 1.5 sand, and 3 ballast. Now from that ratio, we can calculate the quantity of cement that we'll use to cast these columns. We can calculate sand, then we can calculate ballast. So when we start with cement, we know that out of this ratio, cement is 1 out of, now you add all the ratios, so the ratio of cement is 1 out of 1 plus 1.5 plus 3, that is 5.5. Then you'll multiply it by the total volume of concrete that we're going to use, which is, we're using the volume of concrete for that column is 0.24 meters cube. That will give us the volume of cement that we'll use. then we know that this concrete that fills the column is wet, but cement and all other materials will be bought in their dry state. So to reduce that dry weight to wet weight, you will multiply your volume by a factor 1.54 to convert it to dry mass, then multiply by the density. There are some things that we need to know by now, like for example the density of cement being 1440 kilogram per cubic meter, 1440 kilogram per cubic meter. Then once you do your math, you'll get